Chapter 6 on rocks. 6.1 how rocks form. 6.2 the first of the major types of rocks, igneous rocks. 6.3 sedimentary rocks, and 6.4 metamorphic rocks. Now our objectives for 6.1 differentiate among the three major types of rocks, compare and contrast the processes in the rock cycle. Here's a vocabulary list. Now we have something called a learning target. This is what you should be able to do as a student after this section. So first, I can name the three major types of rocks. Then I can label the processes in the rock cycle for each type of rock. Now in general, a rock is a group of minerals bound together. Igneous rocks, sedimentary rocks, and metamorphic rocks are formed, broken down, and reformed in a recurring process called the rock cycle. So here are our processes. Let's start with sedimentary rocks, or sediments. So we have sediments that come from rivers, streams, anything that has broken down rock. That rock could have been sedimentary rock, metamorphic rock, or igneous rock. And it has gone through weathering and erosion. So weathering and erosion is the processes that form sediments. Now that sediment can be eroded again and then recycled back into weathering and erosion or uplifting to form new sediments, or sediments can be deposited, buried and compacted, cemented together to form sedimentary rock. So to form sediments, it must go through uplifting and weathering and erosion, and then to form sedimentary rock, it must go through deposition, burial, compaction, cementation. Now to form a metamorphic rock needs to go through heat and or pressure. This is called metamorphism. Now metamorphic rock can then go through melting to form lava. Sedimentary rock can go through melting, and then it can solidify to form an igneous rock. Now this igneous rock can go through weathering and erosion, uplift, weathering and erosion to form sediment. It can go through heat and pressure to form metamorphic rock, or it can melt to form to form lava, which then forms a new igneous rock. Now notice in this cycle, you can be at any type of rock and go through another process to form any other type of rock. So let's give you a couple examples here. Let's say we have sandstone that gets melted and formed lava. That lava solidifies to form granite. Let's take that same sandstone, gets weathered and eroded, uplifted, forms sediment, and then it could be buried, compacted, cemented together to form a different type of sandstone. That sedimentary, or the same sandstone. Now that sedimentary rock can go through a tremendous amount of heat or pressure, and it can actually form quartzite, which is a metamorphic form of sandstone. Now in 6.2, we break down to igneous rocks. The objectives on this are distinguish between intrusive and extrusive igneous rocks and how they form. Contrast the types of plutons that form as a result of intrusive igneous activity. Here's our vocabulary here. We have felsic, mafic, pluton, and batholith. Now in this one, our learning target is being able to identify in the igneous rock lab to identify the different types of igneous rocks. And that's the same for all the three different types of rocks. The learning targets are part of the actual lab to identify those types of rocks when given as samples. So igneous rocks form as molten rock solidifies. Now as magma deep in Earth's crust, that's called intrusive. So if it's on the inside of Earth's crust, that term is intrusive. Or lava at Earth's surface, if that cools, that's called extrusive. So intrusive is inside Earth's crust, extrusive is outside of Earth's crust. Now the igneous rock texture depends mainly on the rate at which magma cools or lava cools. Now felsic magma form light-colored, silica-rich rocks. The mafic magmas form dark-colored rocks rich in iron and magnesiums. So you can see here's a granite. We have This is a very common type of igneous rock. This is a felsic from felsic magma. Basalt, which is found in great amounts on the bottom of the ocean floor, this is basalt. This is a mafic magma. You can see the dark colored, rich iron and magnesium color in this one. Now, when that lava is deep inside Earth's crust and it starts to cool, certain minerals will start to crystallize before others. That series of crystallization is called Bowen's reaction series. So we have very high temperatures. Actually, olivine, which was in our mineral practical, in our mineral lab, olivine is one of the very first minerals to actually start to crystallize. We also have some plagioclase feldspars that start to crystallize as well. So you can see here there's a series of crystallizations, and they give you a couple examples. Quartz is actually one of the last minerals to crystallize among this series based on its temperature. So low temperature, late crystal. Now when you're looking at the different types of rocks, igneous rocks, the ultramafic rocks, so very dark, very olivine rich or plagioclase rich rocks, those are ultramafic rocks. The basaltic rocks then form next, andesitic and granite. And one thing that you'll see is the color becomes lighter. So ultramafic and basaltic sometimes are hard to differentiate because they're both very dark. And then you have andesitic, which is a little lighter. Those are like the grays. And then the granitic are very light colored, cream color or white colored rocks. So what type of magma was this sample formed from, and identify the name of the sample? So it's a light color. So what type of magma? Remember, we have either felsic or mafic. Okay, so it would be from felsic, and when you're looking at the different types of crystals, it'd be made out of quartz, mostly quartz and some other micas, so it's probably a granite. How about this one? We have basaltic, so this would be mafic. And you can see here, this one took a little longer to form, so the crystals are a little larger. This one has very small microscopic crystals in it, but they're both basalt. Now this one's a mixture. You can kind of see the gray in here. You can see the white crystals, the pink in here, a little bit of sodium. When you're looking at something like this, it's kind of in between. So this would be an andesitic. So this would be andesite. This comes from felsic lava. Now this one's a little tricky. This is actually, I know it looks dark, but this is actually felsic, comes from felsic rock or felsic lava. Now this one, if you were to place a cup of water and you put a small drop of food coloring in it, what's going to happen to the water? Well, eventually the whole water will turn whatever color that food coloring is. It's the same concept with this. You had an amount of felsic lava with a small amount of, let's say, biotite mica. Well, that biotite mica acted kind of like that dye, and it cooled so fast that it didn't have time for crystals to grow. It didn't have time for that biotite to get back together and form a small crystal of biotite. And so it discolored the entire sample of felsic lava and actually became, in this case, it's called obsidian. So igneous rocks are grouped into families by mineral composition and texture. The first is the granite family, that's all the felsic rocks. The gabbro family, all the mafic rocks, and the diorite family, these are the intermediate rocks. Here's the chart, the summary chart for igneous rocks. The texture, coarse grain, which means the crystals are, you can visibly see them without any microscope or lens or anything like that. You can visibly see the crystals in it. Very fine grain. You can somewhat see small crystals, but they're very small. It would probably take a magnifying glass to see them. And then you have glassy, Literally, it just looks like glass. And then you have porous. And the two most common igneous types of rocks with porous texture are pumice. Notice how pumice, though, is in the felsic composition, and then scoria, which is in the mafic. Typically, scoria is a little darker. Those are what we call lava rocks. And then pumice actually are used, they have several commercial uses, and both of which, the porosity texture comes from pockets of gas that are released when the rock forms. And those pockets of gas, the gas is released, and then what's left over are small vesicles. Now, magma that solidifies underground forms various types of igneous intrusions. Now, these igneous intrusions, the largest is a batholith, and you can kind of see down here. Go back. You can see there are different types. You have a volcanic neck, a laccolith. Now, the difference between a dike and a sill, the dike is vertical, the sill is horizontal. So if you're looking at something like this and identifying this rock feature, you can see the dark areas here. It's an entire layer, and it's near the surface. So this would be considered a laccolith. These ones here, this one's horizontal, so this is a sill. You can see this intrusion is very dark in these areas and it's lighter around it, so this dark mafic magma came up and rose up and solidified and cooled off, so the mafic lava cooled off. This would be another laccolith. Now this one is vertical, this one is a dike. And another one that's exposed here, but this one is massive. The picture on this doesn't do it justice. This is a very, very large mafic lava igneous intrusion, and this was actually one of the batholiths. Now this one's almost an entire mountain range as well. This one before it is underwater. You can't really see most of it. This one is pretty obvious. It's most of a mountain range. The batholith is the largest igneous intrusion feature. And here's another picture of the batholith in the Sierra Nevadas. So you can see the huge plume of magma. It's actually been overgrown by some vegetation as well. Now in 6.3, sedimentary rocks, again identifying, being able to name, giving a sample what a sedimentary rock is. There's your vocabulary terms for each one of these. So sedimentary rocks form from sediments that result from weathering and erosion of rock at Earth's surface. Now they often occur in layers, formed over time as different sediments are deposited on top of each other. Now clastic sediments are often sorted by water action before pressure and mineral cements turn them into the rock. So in this example, we have a three-step process. First, a river moves sediments into lake. The weathering and erosion takes place around it. Those sediments are put into the lake. A river then is the transport into that lake. And the sands and gravels, the larger sediments, are the first to be deposited, then the sands, and then the silts and clays. Now the second stage, the particles are sorted by size. The largest gravels are the first to be deposited, followed by sands and then silts and clays. And third, over time, the sediments are compacted, buried, and may be cemented together and form a sedimentary rock. So in this case, the larger sediments make up the sedimentary rock conglomerate. The sands, the intermediate sized sediments, form sandstone, and then the very fine sediments, the silts and clays, will form shale. Now calcite dripstones form from calcite saturated groundwater in caves. So the way that these sedimentary rocks form are clastic sediments, formed from clastic sediments. You also have some from chemical processes like calcite and the dripstones. And we also have some here, the chemical form of chemical way that sedimentary rocks form is also evident in Death Valley in California, where salt is produced by evaporation of mineral-rich water. This happens in the desert basin, where the water evaporates and the sediments form together to form, or fuse together to form salt. They're compacted, cemented together. Now, sedimentary rocks are grouped by the type of sediment from which they form. We have the clastic, the chemical, and the one that we haven't talked about yet is the organic. And here are a couple examples of each. Clastic, the sandstone; the chemical, the rock salt, just like in Death Valley in California. And then another one is organic. And if you remember what organic means, it once was living. And here's an example of limestone cliffs. Limestone is a very common organic sedimentary rock. And the limestone actually comes from the shells of shallow seas around the planet in Earth's past that have compacted together and cemented together, and they actually form limestone. All right, so let's check these out. The first here, you see the layers. So that's right away one of the clues that it is a sedimentary rock. And you can see here that as it's compacted together over time, over millions of years, the sediments in it, and in this case it'd probably be an intermediate, you can tell. We'd have to get a closer sample, but it could be sandstone. There could be some type of other clastic type of rock, but it would be clastic. And again, here you can see the particles, the small sediments and the large sediments, and you can definitely tell that the river transported these and will continue to transport the sediment, forming another type of clastic rock. Could be sandstone, shale, any of the clastic types of sedimentary rocks. Now, fossils, ripple marks, mud cracks, and nodules, concretions, and geodes are all features associated with sedimentary rocks. Now, fossils, obviously, from any living animal at one time, it was buried and compacted within that sedimentary rock, and then the fossils will be trapped, or not trapped, but they will be sitting in that sandstone and can be found by archaeologists, or fossils are found quite often in different parts of the world. Now, the ripple marks in this picture come from the wave action and the tidal action and the water movement, and so sometimes ripple marks are evidence that there was water at one time. Mud cracks as well, those cracks in the sedimentary rock, at one time there could have been water. Nodules, concretions, could be small features of stone that, in geodes, small features of stone that need water to form. One interesting thing is we do have nodules on Mars. We have found those on Mars, so that's one piece of evidence that there was once water on Mars. And our last type of rock is metamorphic rock. And again, we're looking at the processes from the rock cycle, and now we need to be able to identify the metamorphic rocks. Now here's an example of a conglomerate, like a sedimentary rock, that goes through metamorphism. And so we have clastic sediment. A conglomerate is sedimentary rock consisting of larger sediments. And let's say it undergoes pressure, huge amounts of pressure. It flattens and stretches those sediments, and it becomes more compact. And then this third photograph right here is the photo of the conglomerate, but it has undergone metamorphism. And you can see how flattened and squished and compacted that these sediments that used to be round, now they're flattened. So this would be an example of the metamorphic rock. So this is metamorphism. Now, metamorphism can change across an entire region, like if a mountain's forming, or it can happen in a small local area. Now, that one type of contact metamorphism is where a magma chamber comes up and intrudes, so it's an intrusive igneous formation, intrudes, and it comes in contact with the rock that surrounds it. In this case, the shale is closest to the magma, and it starts going through huge amounts of heat, and as that temperature decreases, there's less metamorphism that occurs on the outside, away from the magma chamber. There's more metamorphism that occurs closer in. So there's different levels of metamorphism as well. So let's walk through an example. Metamorphic rocks form when heat or pressure or both alter a parent rock, which is also called a pre-existing rock. So let's start with shale, which is a sedimentary rock. Goes through somewhat of a degree of metamorphism. It's still high heat, high pressure. We're talking 600-700 degrees temperature or a huge amount of pressure, and it can form slate. Well, let's say it goes through even more heat and pressure, and it can become phyllite. Now, phyllite will be even more compacted. You'll start to see kind of a luster to it, and then now that phyllite goes through even more heat and pressure, and it can become schist. Now, schist is even more compacted, more dense, and new crystals can actually form on it as well. Now, metamorphic rock may be described and identified according to its parent rock, mineral composition, and texture. So again, we have shale. The first degree is slate, so fine grain, more compact, it's hard to see the straight horizontal layers that you would see in shale. So they're kind of broken down and start to twist and turn. And then phyllite, you can definitely see it's more compacted. It's hard to see the layers at all, and you have a sheen to it, kind of a luster to it. And then schist, very compact, sometimes even shiny, or the luster is very, very bright. And let's break it down one last time with the outline. So how rocks form, what is a rock, the rock cycle, and in section 2, the igneous rocks, what they start with, the underground magma, the different types, and then what happens at the surface. Talked about the 3 different types of families and the other igneous intrusions. Sedimentary rocks, the clastic, the chemical, the organic, stratification, which is the layering, the fossils, ripple marks, mud cracks, all the other features of sedimentary rocks. And then metamorphic rocks, the process, regional, across the entire mountain, local, where it's small right next to the magma chamber, and then we went through a couple of the metamorphic rock descriptions. There we go, chapter 6.